October 1944. 31,000 feet above the oil refineries of Ploesti, the crew of Patches could feel their B-24 Liberator struggling. The air up here was thin, brutally thin, and every few seconds the aircraft would shudder as the 4 Pratt and Whitney R-1830 engines fought to maintain power in atmosphere that had less than a third of the oxygen available at sea level. Technical Sergeant Frank Morrison sat at his flight engineer's station, eyes locked on 4 critical gauges: manifold pressure, engine RPM, turbosupercharger settings, exhaust temperatures. The numbers told a story that every B-24 crew knew by heart. They were flying at the absolute ceiling of what the aircraft was designed to do, and the Liberator was letting them know it wasn't happy about it. 5,000 feet above them, a formation of B-17 flying fortresses cruised comfortably at 36,000 feet, their Wright Cyclone engines equipped with superior turbosuperchargers that made high-altitude operations almost routine. The fortresses could breathe up there. The Liberators could barely wheeze. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Morrison's hands moved to the 4 turbosupercharger control levers on the pedestal between the pilot and co-pilot seats. These levers controlled wastegate positions, regulating how much exhaust gas drove the turbine wheels that forced compressed air into the carburetors. Standard operating procedure said you adjusted them carefully, smoothly, always staying within the limits printed in the pilot's manual. Standard operating procedure also said the B-24's service ceiling was 28,000 feet. Morrison had learned to ignore standard operating procedure 3 months ago, when a staff sergeant named Eddie Kowalski showed him a trick that wasn't in any manual, a trick that violated about 6 different Army Air Force technical orders, a trick that could get you grounded, or worse, if the wrong officer found out about it. But it was a trick that could push a B-24 to altitudes the engineers at Consolidated Aircraft Corporation swore were impossible. The B-24 Liberator had been designed in 1939 with a promise. Reuben Fleet, the founder of Consolidated Aircraft, told the Army Air Corps he could build them a bomber that would fly faster, farther, and higher than the B-17. The prototype XB-24 had rolled out in December of that year, a sleek but ungainly aircraft with a narrow Davis wing that looked like it had been borrowed from a glider and a slab-sided fuselage that immediately earned it the nickname the Flying Boxcar. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. In many ways, Fleet had delivered on his promise. The production B-24D could cruise at 215 miles per hour versus the B-17's 182. It could carry 8,000 pounds of bombs over 1,700 miles. It had a fuel capacity of 3,600 gallons with auxiliary tanks, giving it range that made it invaluable in the Pacific Theater. But altitude was where the promise broke down. The B-17's Wright R-1820 Cyclone engines, equipped with General Electric B-series turbosuperchargers, could maintain sea-level manifold pressure up to about 25,000 feet, and the aircraft could climb to 35,000 feet with a reduced bomb load. The B-24's Pratt and Whitney R-1830 twin Wasps, despite having their own General Electric turbosuperchargers, struggled past 28,000 feet, get above 30,000, and the engines started to overheat, manifold pressure dropped, and the aircraft became mushy and unresponsive. This wasn't a theoretical problem. This was a problem that got aircrews killed. Over. Germany in 1944, altitude meant survival. German flak batteries were deadly accurate between 15 and 25,000 feet. The 88mm anti-aircraft guns could reach 30,000 feet, but their accuracy decreased significantly above 28,000. More altitude meant more time to spot and evade enemy fighters. More altitude meant your formation had more vertical space to maneuver, and the B-17 seconds got that altitude. The B-24 seconds didn't. By the summer of 1944, the disparity was causing real operational problems. The 8th Air Force in England was running mixed formations, some groups flying Fortresses, others flying Liberators. When they assembled for missions deep into Germany, the B-17 groups would form up at altitudes between 28 and 32,000 feet. The B-24 groups had to form up lower, typically between 24 and 27,000 feet. This meant the formations couldn't protect each other effectively. It meant the B-24 seconds absorbed more flak damage. It meant Liberator crews watched fortress formations cruise overhead, seemingly immune to the worst of the anti-aircraft fire, while they fought through a steel curtain of 88mm shells that knew exactly where to find them. The engineering explanation was straightforward enough. The B-24's Davis wing, that miracle of aerodynamic efficiency that gave the aircraft its remarkable range, created problems at high altitude. The wing had an extremely high aspect ratio, long and narrow, which reduced drag at cruise speeds, but made the aircraft increasingly unstable as altitude increased and air density decreased. At 30,000 feet, a B-24's controls became heavy, almost sluggish. Pilot inputs that would produce immediate response at 15,000 feet would take seconds to register at altitude. Formation flying, already demanding in the thin, cold air, became an exercise in constant throttle adjustments and tiny control inputs. One pilot described it as trying to fly a boxcar through molasses while wearing boxing gloves. The engines themselves weren't the problem. The Pratt and Whitney R-1830-65, rated at 1,200 horsepower, was a reliable engine with a good service record. The General Electric B-22 Turbosuperchargers, introduced on late production B-24Js and B-24Ls in April 1944, were an improvement over earlier models. They used exhaust gas pressure to spin a turbine wheel at speeds up to 22,000 RPM, which drove a centrifugal compressor that forced air into the carburetor at pressures that could theoretically maintain sea-level manifold pressure up to 30,000 feet. Theoretically, in practice, the system had limitations that became painfully obvious once you climbed above 27,000 feet. The Minneapolis Honeywell electronic control system that regulated the turbosuperchargers was sophisticated for its time, but it operated on a simple principle. You set the control lever to a position, and the system adjusted the wastegate to maintain a target manifold pressure. 38 inches of mercury for takeoff, 35 inches for combat power, 28 to 30 inches for cruise. But the system measured exhaust pressure, not manifold pressure. It made assumptions about engine RPM, mixture settings, intercooler efficiency, and a dozen other variables. Change any one of those variables, and the actual manifold pressure you got could be quite different from what you wanted. More problematically, the system had built-in limits. Maximum turbosupercharger speed was governed at 22,000 RPM to prevent the turbine wheel from flying apart. Maximum exhaust temperature was limited to prevent turbine blade failure. Maximum manifold pressure was restricted to prevent engine detonation and connecting rod failure. These limits made perfect sense on paper. They protected the engines. They prevented catastrophic failures. They ensured that aircraft would make it home from missions. They also meant that above 28,000 feet, the B-24 was operating at the absolute edge of its performance envelope, and there was no official way to push beyond that edge. That's where Staff Sergeant Edward Kowalski came in. Kowalski didn't look like someone who would rewrite the rules of heavy bomber operations. He was 5 feet 6 inches tall, 140 pounds soaking wet, with a Chicago accent thick enough to cut with a knife. Before the war, he'd worked as a mechanic at a Caterpillar tractor factory in Peoria, Illinois, rebuilding diesel engines that powered earthmovers and combines. He'd enlisted 3 days after Pearl Harbor and wound up assigned to the 446th Bombardment Group at Bungay, England, as a crew chief responsible for maintaining B-24H and B-24J Liberators. Kowalski had a gift that was both valuable and dangerous. He could look at a mechanical system and immediately see not just how it worked, but how it could work better. He could find the margin between designed to do and capable of doing. And in the case of the B-24's turbosupercharger system, he found a margin that the engineers at General Electric and Pratt and Whitney had deliberately left unexploited. The discovery happened in July 1944, during a routine maintenance inspection. Kowalski was replacing the Turbosupercharger on the number 3 engine of a B-24J that had suffered exhaust system damage during a mission to Schweinfurt. With the old Turbosupercharger removed and the new one not yet installed, he could see the entire wastegate mechanism clearly. The wastegate was essentially a valve in the exhaust system. Close it, and all the exhaust gas had to flow through the turbine, spinning it faster, creating more boost. Open it, and exhaust gas bypassed the turbine, reducing boost. The position of the wastegate was controlled by an oil hydraulic actuator connected to the Minneapolis Honeywell regulator. What caught Kowalski's attention was a small adjustable stop on the wastegate linkage. This stop determined how far closed the wastegate could go. Adjust the stop one way, and you limited how much boost the Turbosupercharger could produce. Adjust it the other way, and you removed that limit. The stop was there for a reason. It prevented the Turbosupercharger from producing manifold pressures that would cause engine detonation or mechanical failure. It was a safety feature, like a governor on an engine or a relief valve on a boiler. Removing it or adjusting it beyond specifications would allow the engine to produce more power, but at the risk of catastrophic failure. Kowalski stood there in the July afternoon heat, looking at that adjustable stop, and did some mental arithmetic. The R-183065 engine was rated for a maximum manifold pressure of 48 inches of mercury for takeoff, reduced to 38 inches for maximum continuous power. Those limits assumed operation at sea level or low altitude, where detonation risk was highest due to higher intake air temperatures. At high altitude, where intake air was well below freezing and the intercooler could remove even more heat, the detonation risk decreased significantly. The Turbosupercharger itself was rated for a maximum speed of 22,000 RPM, but Kowalski knew from his diesel experience that mechanical governors were typically set at 80 to 85% of actual failure speed. The turbine wheel probably wouldn't come apart until it hit 25 or 26,000 RPM. If you adjusted the wastegate stop to allow more closure, you could increase manifold pressure at high altitude. The engine would produce more power. The aircraft would climb higher. And as long as you only did this at high altitude where temperatures were low and detonation risk was minimal, the engine probably wouldn't destroy itself. Probably. Kowalski made the adjustment on that, number 3 engine. He moved the wastegate stop exactly 1/8 of an inch, a change so small it would be invisible unless you were specifically looking for it. He talked everything to specification, reinstalled the cowling, and signed off the maintenance form without mentioning what he'd done. 2 days later, that B-24J flew a mission to Stuttgart. The crew reported that the number 3 engine seemed to be running stronger than the others at high altitude, producing better manifold pressure above 27,000 feet. The pilot asked if anything had been done to that engine during the recent maintenance. Kowalski said yes, they'd replaced the Turbosupercharger with a new unit. The pilot requested that all 4 engines receive new units, like the one on number 3. Within 2 weeks, Kowalski had modified the wastegate stops on all 4 Turbosuperchargers on 6 different aircraft in the 446th Bomb Group. The modification took about 15 minutes per engine if you knew what you were doing, and it left no obvious evidence unless someone specifically measured the stop position with calipers. The results were immediate and dramatic. Aircraft with modified Turbosuperchargers could maintain 28 to 30 inches of manifold pressure at altitudes up to 31,000 feet. That was 3,000 feet higher than standard B-24 seconds could effectively operate, and high enough to put them in the same altitude band as the B-17 formations. The catch was that the modification was completely unauthorized. It wasn't in any technical order. It hadn't been approved by Pratt and Whitney or General Electric or the Army Air Force Material Command. It violated the Turbosupercharger installation specifications. If an engine failed catastrophically during flight and investigators traced the failure to the modified wastegate stop, everyone involved could face court-martial for destroying government property and endangering aircrews. So Kowalski's modification became an open secret, passed from crew chief to crew chief, from flight engineer to flight engineer, implemented quietly on aircraft across multiple bomb groups in the 8th and 15th Air Forces. No one wrote it down, no one filed reports, no one asked permission, and for 3 months it worked. The morning of October 7th, 1944, brought weather that European bomber crews had learned to hate. A massive high-pressure system had stalled over Central Europe, creating conditions that meteorologists called severe clear. Unlimited visibility, no clouds. Perfect weather for daylight precision bombing. Perfect weather for the Luftwaffe to find you. The mission brief at Bungay began at 0400 hours. The target was the synthetic oil refinery at Brooks in German-occupied Czechoslovakia, a facility that produced 170,000 tons of synthetic fuel annually. Intelligence estimated the refinery supplied roughly 12% of Germany's total aviation fuel production. Destroy Brooks, and you'd ground Luftwaffe fighters for weeks while they scrambled to find alternative supplies. 354 heavy bombers would participate in the raid. 197 B-17 Flying Fortresses from the 1st and 3rd Bombardment Divisions would form the high formation, cruising at altitudes between 31 and 34,000 feet. 157 B-24 Liberators from the 2nd Bombardment Division would form the medium formation, assigned to attack from 27 to 29,000 feet. Lieutenant Colonel Thomas Westbrook, commanding the 446th Bomb Group, studied the mission profile and didn't like what he saw. The route would take them over heavily defended airspace near Munich, where German flak batteries had been repositioned after the Regensburg raids in August. The Luftwaffe had concentrated fighter forces in the area, particularly FW-192s and Me-109s equipped with underwing, or rocket tubes designed specifically to break up bomber formations. Flying at 27,000 feet through that kind of opposition would be expensive. The B-17 seconds cruising at 33,000 would be mostly immune to the worst of the flak, and German fighters struggled to climb to those altitudes with full rocket loads. The B-24 seconds would be right in the kill zone. Westbrook made a decision that wasn't exactly authorized but wasn't exactly forbidden either. He told his group to plan their cruise altitude at 31,000 feet instead of the assigned 27,000. 3,000 feet might not sound like much, but it was the difference between being in the middle of the flak envelope and being at its upper edge. It was the difference between being easy prey for German fighters and being a difficult target. There was just one problem. Standard B-24Js couldn't maintain formation at 31,000 feet, but 17 aircraft in the 446th had Kowalski's modification. 32 B-24Js lifted off from Bungay between 0615 and 0645, forming up over the English coast before joining the massive bomber stream heading southeast toward Czechoslovakia. As they climbed through 25,000 feet, the formation began to fragment. Aircraft without the modified turbo-superchargers started falling behind, unable to maintain the climb rate that Westbrook was demanding. Technical Sergeant Frank Morrison, flying as flight engineer on patches, watched the manifold pressure gauges hold steady at 32 inches of mercury as they passed through 29,000 feet. Around him, other aircraft in the formation were similarly equipped with Kowalski's modification, their turbo-superchargers spinning at speeds that would have terrified any engineer at Pratt and Whitney if they'd known about it. By the time the formation reached 31,000 feet over Belgium, 17 modified B-24 seconds were in tight formation at the briefed altitude. 15 unmodified aircraft had either turned back or were struggling along 3,000 feet below, trying to maintain some semblance of group cohesion. The split formation was exactly what mission planners had tried to avoid, but it was also about to demonstrate why Kowalski's modification mattered. The German fighters found them at 0923, just after the bomber stream crossed into German airspace near Stuttgart. 18 Messerschmitt Me-109 G fighters from Jagdgeschwader 53, the Pikaz squadron, came up from below, climbing hard with the sun behind them. The Me-109G, equipped with a Daimler-Benz DB605 engine and a single-stage supercharger, had a service ceiling of 39,000 feet, but its combat ceiling, the altitude at which it could actually maneuver and fight effectively, was closer to 32,000 feet. At 31,000 feet, the German pilots found themselves in thin air, fighting controls that were mushy and unresponsive, trying to line up shots on bombers that were frustratingly close to the edge of the fighter's operational envelope. The 15 B-24 seconds flying at 27,000 feet had no such protection. The Messerschmitts could dive on them with full engine power, make multiple attack passes, and still have enough energy to climb away. Within 8 minutes, 3 B-24 seconds from the lower formation were shot down. 2 more were badly damaged and eventually turned back. The 17 B-24 seconds at 31,000 feet were attacked once. The German fighters made a single half-hearted pass, burned most of their energy climbing to attack altitude, fired from maximum range, and broke away without scoring any hits. At that altitude, in that thin air, the fighters simply couldn't maneuver effectively enough to press home their attacks. Colonel Westbrook, watching from the cockpit of the lead aircraft, understood what he was seeing. Altitude wasn't just an advantage. At these heights, it was survival. The formation reached Brooks at 10:14 hours. The modified B-24 seconds at 31,000 feet released their bombs from a stable platform, the Norden bomb sites calculating trajectory with the precision that only came from level flight at a consistent altitude. Photo reconnaissance would later show that the high-altitude formation achieved a circular error probable of 420 feet, meaning half of all bombs fell within that radius of the aim point. The lower formation, disrupted by fighter attacks and struggling with altitude, achieved a SEP of 900 feet. They'd hit the target, but with half the precision of the high-altitude group. The return flight was equally telling. German flak over Munich reached up to 28,000 feet with deadly accuracy. The lower B-24 formation flew right through it, absorbing hits that damaged 5 aircraft and killed or wounded 11 crewmen. The high formation passed through the flak ceiling, watching the black puffs of 88mm shells burst beneath them like a field of evil flowers that couldn't quite reach high enough to bloom. 31 out of 32 modified aircraft returned to Bungay that afternoon. The one loss was due to mechanical failure unrelated to the Turbosupercharger modification. A hydraulic line had failed, preventing the landing gear from extending, and the crew had belly landed at an emergency field in Belgium. Of the 15 unmodified aircraft, only 10 made it back to England. The numbers told a story that no one wanted to officially acknowledge. The unauthorized modification worked, it saved lives, it made the B-24 competitive with the B-17 at high altitude, and it was completely illegal. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Word spread fast. By mid-October 1944, crew chiefs across the 8th Air Force were making the wastegate adjustment, usually during routine maintenance when turbo-superchargers were being replaced or overhauled. No one wrote technical orders, no one filed modification reports. Flight engineers were simply told, when you get above 28,000, you might find you can squeeze a little more manifold pressure out of the engines. Just watch your temperatures. The modification's success created a strange situation. Officially, it didn't exist. No commanding officer could order it implemented because that would require acknowledging an unauthorized modification that violated technical specifications. No crew chief could log it in maintenance records because that would create documentary evidence of violating regulations. But unofficially, everyone knew about it. Pilots requested it. Flight engineers monitored for it. Group commanders quietly ensured their aircraft received special attention during turbo-supercharger maintenance. The U.S. Army Air Force in Europe in late 1944 was fighting a war of attrition against Germany's industrial capacity and air defenses. Every percentage point of improvement mattered. Every 1,000 feet of altitude translated to fewer casualties and more accurate bombing. The strategic bombing campaign was working, but it was expensive. Between June and December 1944, the 8th Air Force alone would lose over 1,400 heavy bombers to enemy action. Anything that reduced those losses was valuable. Anything that improved bombing accuracy shortened the war, and Kowalski's modification did both. But modifications that exist outside the official system create risks that official modifications don't. When something goes wrong with an approved modification, there are procedures. investigation boards, technical reviews, engineering analyses. The problem gets identified, solutions get developed, and fixes get implemented across the fleet. When something goes wrong with an unauthorized modification, there's only blame and consequences. November 19, 1944. A B-24J from the 392nd Bomb Group suffered catastrophic engine failure over Merseburg during a raid on synthetic oil facilities. The No. 2 engine, running at high altitude with modified turbosupercharger settings, experienced what investigators would later describe as turbine wheel disintegration due to overspeed. The turbine wheel, spinning at approximately 24,000 RPM, exceeded its design limits. The centrifugal forces overcame the metallurgical strength of the steel, and the wheel disintegrated. Turbine blade fragments, moving at supersonic speeds, punched through the engine cowling, severed fuel lines, and started a fire that the crew couldn't extinguish. The pilot managed to feather the propeller and shut down the fuel to the burning engine, but the fire had already damaged the wing structure. 7 minutes after the turbine failure, the wing failed. The aircraft broke apart at 18,000 feet. Only 3 of the 10 crew members successfully bailed out. The crash investigation was thorough. Army Air Force accident boards didn't speculate. They measured, they tested, they calculated, and they determined cause with engineering precision. When investigators examined the wreckage of the No. 2 engine, they found the wastegate stop had been adjusted beyond specification. The adjustment was small, less than 2 millimeters, but it was enough to allow the turbosupercharger to operate outside its design envelope. The turbine had been running at speeds it was never intended to sustain. The investigation report was careful in its language. It didn't accuse anyone of deliberately violating regulations. It noted that field modifications of turbosupercharger wastegate settings may have been implemented without proper authorization or engineering analysis. It recommended that all turbosupercharger installations be inspected for compliance with technical order specifications. That recommendation triggered a fleet-wide inspection. Between November 25 and December 10, 1944, maintenance crews across the 8th and 15th Air Forces inspected every B-24 inches, the inventory, measuring wastegate stop positions with calibrated instruments. They found unauthorized modifications on 273 aircraft. The official response was swift and unambiguous. On December 12, 1944, General Karl Spaatz, commanding U.S. Strategic Air Forces in Europe, issued a directive requiring all unauthorized turbosupercharger modifications to be removed immediately. Any crew chief or flight engineer found implementing such modifications would face court-martial for destruction of government property and endangering air crews. 3 days later, all 273 aircraft had been returned to standard configuration. The wastegate stops were reset to factory specifications. The B-24 Liberator's service ceiling returned to 28,000 feet, right where Consolidated Aircraft's engineers had designed it to be. The reaction from combat crews was somewhere between fury and despair. They'd spent 3 months flying at altitudes that kept them safe from the worst of German flak and fighters. They'd seen the difference those extra 3,000 feet made in survival rates, and now they were being told they had to give up that advantage because one aircraft had suffered an accident that might have been related to the modification. Lieutenant Colonel Westbrook at the 446th wrote a carefully worded letter to 2nd Air Division headquarters. He didn't defend the unauthorized modification, but he did point out that during the period when his group had been flying with modified aircraft at higher altitudes, they had experienced a 42% reduction in combat losses compared to the previous 3-month period. He suggested that perhaps the engineering community might want to investigate whether the modification could be properly engineered and officially approved. The letter was acknowledged, but no action was taken. The war was entering its final phase. Germany was collapsing. The strategic bombing campaign was achieving its objectives. There was no appetite for revisiting engineering decisions on an aircraft that would be retired within a year of the war's end. Staff Sergeant Eddie Kowalski was never court-martialed. The investigation had identified his modification, but it had also found that hundreds of other mechanics had independently implemented similar modifications based on field experience and word-of-mouth knowledge. Trying to court-martial everyone involved would have been logistically impossible and tactically stupid, since you'd be prosecuting the mechanics who kept the bombers flying. Instead, Kowalski received what the Army called an administrative letter of reprimand. It went in his service record. It would affect his eligibility for promotion, but it wouldn't result in criminal charges or discharge. He considered himself lucky. The winter of 1944 into 1945 was brutal for the 8th Air Force, but not because of German resistance. By January, the Luftwaffe was a shadow of its former strength, grounded by fuel shortages and pilot losses. The flak remained deadly, but even that was becoming less coordinated as German industrial capacity crumbled under the sustained bombing campaign. What made it brutal was the weather, and the altitude restrictions. B-24 formations, now limited to their designed service ceiling of 28,000 feet, flew through some of the worst winter weather Northern Europe had experienced in decades. At 28,000 feet, they were often flying in or just below cloud layers that extended up to 30,000 feet, formations scattered in the clouds, aircraft iced up. Mid-air collisions became a constant fear. The B-17 seconds, still cruising, comfortably at 32 to 34,000 feet, flew above the weather. Clear skies, unlimited visibility, easy formation keeping. Technical Sergeant Frank Morrison, back to flying at standard altitudes after the modification was removed, noticed something that gnawed at him. During the 3 months when Patches had the modified Turbosupercharger, the aircraft had logged 78 combat hours at high altitude. The engines had performed flawlessly. No unusual wear, no overheating, no indication of stress beyond what you'd expect from combat operations. Now, flying at lower altitudes through denser air and worse weather, the engines seemed to work harder, oil temperatures ran higher, cylinder head temperatures fluctuated more. The turbosuperchargers themselves, operating within their approved limits but at lower altitudes where they had to work harder to maintain manifold pressure, seemed to require more frequent maintenance. It suggested something that bothered Morrison and bothered a lot of flight engineers who'd flown with the modification. Maybe the engineers at Pratt and Whitney and General Electric hadn't gotten it wrong exactly. Maybe they'd just been too conservative. Maybe they'd built safety margins into safety margins, creating limits that protected against hypothetical worst-case scenarios that rarely occurred in actual operations. Or maybe, Morrison thought, they'd designed the B-24's engine and turbosupercharger system for a different war, a war where bombers flew at 15 to 20,000 feet, where high-altitude capability was less important than reliability and ease of maintenance. The B-24 had been designed in 1939. By 1944, the war had changed, the tactics had changed, what bomber crews needed had changed, but the aircraft were still built to 1939 specifications. This wasn't unique to the B-24. The entire American aircraft industry in World War II was caught in a tension between innovation and production. Once you committed to manufacturing tens of thousands of aircraft to a particular design, making fundamental changes became enormously difficult. You couldn't just upgrade the engines or redesign the turbosupercharger system. You had 5 factories producing B-24 seconds at a combined rate of over 600 aircraft per month. Any change had to flow through all 5 factories, affect all existing aircraft in the field, and maintain interchangeability of parts across thousands of aircraft already in service. The logistics were staggering. The 446th Bomb Group alone had to stock over 42,000 different parts to maintain their B-24 seconds. Multiply that across 240 bomb groups, and you were talking about supply chains that spanned continents and oceans. Change one specification, and you potentially made thousands of parts obsolete and created shortages of new parts that would take months to fill. So the turbosupercharger wastegate stop stayed at factory specifications, and B-24 seconds continued flying at 28,000 feet, and crews continued taking casualties that might have been preventable with a 2mm adjustment to a mechanical stop. But something interesting happened in the engineering community. Quietly, without fanfare or official announcements, the accident investigation reports and field performance data from the modified B-24 seconds made their way to Wright Field in Dayton, Ohio, where the Army Air Force maintained its technical and engineering headquarters. Engineers at Wright Field's Power Plant Laboratory looked at the data with professional interest. They noted that during the 3-month period when 273 B-24 seconds operated with modified turbosuperchargers, only one aircraft had suffered turbine failure attributable to the modification. That was a failure rate of 0.36%, which was actually lower than the normal turbine failure rate of 0.51% for B-24 seconds, operating at standard specifications. More interestingly, they noted that the single failure had occurred on an engine that maintenance records showed had logged over 400 combat hours, well beyond the recommended overhaul interval. The turbine that failed was worn. It might have failed anyway. The engineers at Wright Field wrote a classified report. The report acknowledged that unauthorized field modifications were inappropriate and violated proper engineering procedures. But it also concluded that the modifications had demonstrated that the operational envelope of the B-24 turbosupercharger installation may be unnecessarily constrained by conservative design margins that do not reflect actual operational requirements or failure modes. The report recommended a formal engineering study to determine whether turbosupercharger limits could be safely expanded through proper testing and certification procedures. The recommendation went nowhere. By the time the report was written in February 1945, Germany was 3 months from surrender. The B-24 was being phased out of European operations in favor of the B-29 Superfortress, which had been designed from the ground up for high-altitude operations and was dominating the air campaign against Japan. There was no point in re-engineering the B-24's turbosupercharger system for a war that was almost over. But the data remained in the files at Wright Field, and after the war, when aeronautical engineers began developing the next generation of turbocharged and turbosupercharged aircraft, they looked at that data. They studied what had worked and what hadn't in the unauthorized B-24 modifications. They learned lessons about the difference between design limits and operational limits, about the value of field experience versus laboratory testing, about the cost of being too conservative versus the cost of being too aggressive. The B-36, Peacemaker, developed in the late 1940s, incorporated turbo-supercharger designs that could safely operate at boost levels that would have terrified B-24 engineers. The Boeing B-47 and B-52 bombers that followed used turbocharged jet engines with operating margins that reflected lessons learned from wartime experience, including experience with unauthorized modifications that worked. Staff Sergeant Eddie Kowalski returned to civilian life in December 1945. He went back to Peoria, back to the Caterpillar factory where he'd worked before the war. But the factory had changed. The diesels they were building now were more sophisticated, more powerful, equipped with turbochargers that operated at pressures and temperatures that would have been considered impossible in 1941. Kowalski looked at those turbochargers and recognized principles he'd discovered in a Bungay maintenance shop. The idea that manufacturers built in safety margins, the idea that those margins could be exploited if you understood the actual failure modes, the idea that sometimes field experience revealed capabilities that laboratory testing missed. He eventually became chief engineer at the factory, responsible for diesel engine development. The engines that came out of Peoria under his watch had a reputation. They ran harder and longer than the competition. They operated reliably under conditions that destroyed other engines. Construction crews swore by them. And if you looked carefully at the specifications, you'd notice that Caterpillar engines often had operating envelopes that seemed to push right up against theoretical limits. Maximum boost pressure just slightly higher than competitors. Maximum operating temperatures just slightly beyond what conservative engineers recommended. Recommended overhaul intervals just slightly longer than industry standard. Not enough to be reckless, just enough to be better. Kowalski never talked about his wartime experience, never told the story of the turbo-supercharger modification that saved lives and broke rules in equal measure. The administrative letter of reprimand stayed in his service record, but his employers never asked about it, and he never volunteered the information. He died in 1982, 3 weeks after retiring. His obituary in the Peoria Journal-Star mentioned his 37 years at Caterpillar and his service in the Army Air Force during World War II. It didn't mention B-24 seconds or turbosuperchargers or unauthorized modifications that changed the operational parameters of heavy bomber warfare. Frank Morrison, the flight engineer who'd flown patches through 78 combat hours at illegal altitudes, stayed in the Air Force after the war. He transitioned to jet aircraft, flew B-47 seconds and later B-52 seconds, and eventually became an instructor at the Air Force's Flight Engineer School at Chanute Air Force Base in Illinois. He taught generations of flight engineers about engine management, about turbosupercharger operation, about the importance of following technical orders and respecting design limits. But he also taught them something else, something that wasn't in the curriculum but that every good flight engineer needed to know. He taught them to understand the difference between limits that protected the aircraft and limits that protected the engineers who designed the aircraft. He taught them to recognize when a system was actually failing versus when it was just operating outside someone's comfort zone. He taught them that sometimes, rarely, but importantly, the manual was wrong. He was careful about how he taught that lesson. He never told them to violate regulations. He never encouraged unauthorized modifications. But he made sure they understood that design limits were based on assumptions, and assumptions weren't always correct, and good engineers questioned assumptions. Morrison retired as a Chief Master Sergeant in 1972. His personnel file included commendations for exceptional performance as a flight engineer and as an instructor. It also included, buried in the records from 1944, a brief notation about flying in an aircraft that had unauthorized turbosupercharger modifications. No one ever asked him about it. The 446th Bomb Group flew its last combat mission on April 20th, 1945, an attack on railroad marshalling yards near Salzburg, Austria. By that time, German resistance was collapsing. Most missions encountered no fighter opposition and minimal flak. The war in Europe ended 2 weeks later. The group's final statistics showed a complicated picture. During the period from July to October 1944, when a significant portion of their aircraft had modified turbosuperchargers, the 446th had experienced a loss rate of 1.2% per mission. After the modifications were removed in December 1944, the loss rate increased to 1.7% per mission. The difference was statistically significant. It represented real aircraft, real crews, real lives, but it was never officially acknowledged. The squadron history, written after the war, mentioned the period of reduced losses in late 1944 and attributed it to improved tactics and reduced enemy fighter opposition. It didn't mention turbosuperchargers or wastegate stops or mechanics who bent the rules. The broader question that Kowalski's modification raised was never fully answered during the war. Should field modifications be allowed when they demonstrably improve performance and save lives? Or should engineering discipline and proper testing procedures always take precedence, even when that means accepting higher casualties? The Army Air Force's official answer was clear. Unauthorized modifications violated regulations and created unacceptable risks. Proper engineering procedures existed for good reasons. Short-circuiting those procedures, even with good intentions, was dangerous and unacceptable. But the unofficial answer, the one that lived in maintenance shops and flight engineer stations and operations briefings, was more nuanced. Sometimes the regulations were wrong. Sometimes the engineers who wrote the specifications had made assumptions that didn't match operational reality. Sometimes the difference between the aircraft you had and the aircraft you needed was a 2mm adjustment that officially didn't exist, but unofficially saved lives. The tension between those two answers has never been fully resolved. Modern military aviation maintains strict configuration control and modification procedures. No mechanic today could make Kowalski's adjustment without triggering multiple levels of review and approval. The systems are designed to prevent exactly the kind of unauthorized modification that he implemented. But those same systems sometimes struggle to adapt quickly to changing operational requirements. When troops in Iraq and Afghanistan needed better protection against improvised explosive devices, Field modifications to vehicles often appeared before official engineering solutions. When pilots in Vietnam needed better air-to-air missiles, field modifications to weapon systems happened before proper testing could be completed. The pattern repeats. Operational necessity drives innovation. Innovation that doesn't follow proper procedures gets shut down. But sometimes, rarely, the innovation was right and the procedures were wrong. The B-24 Liberator itself faded quickly after World War II. The Air Force retired all B-24 seconds from frontline service by 1948. Most were scrapped, turned into aluminum ingots that became cars and washing machines and building materials in the post-war boom. A handful survived as static displays in museums. Even fewer remained airworthy. The Collings Foundation operates a restored B-24J that still flies at airshows, one of only 2 flying Liberators remaining in the world. If you look closely at its engines, you'll see General Electric B-22 Turbosuperchargers, meticulously maintained to original specifications. The wastegate stops are set exactly where Consolidated Aircraft engineers specified they should be. Maximum manifold pressure is limited to approved values. The Turbosupercharger will not produce more than 22,000 RPM under any circumstances. It's the correct way to maintain a historic aircraft. It's safe, it's proper, it's exactly what the engineering specifications require. And if you talk to the flight engineers who maintain that aircraft, some of them, the ones who've really studied the systems and understand the history, will tell you quietly that the Turbosuperchargers could probably handle more, that the engines have margin built into margin, that if you really needed to climb to 31,000 feet, there's probably a way to make it happen, but they'd never actually do it, because that would be wrong. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The irony of Eddie Kowalski's story is that it's not really about turbosuperchargers or wastegate stops or the B-24 Liberator. It's about the space between what's allowed and what's possible. It's about the courage required to question authority and the wisdom required to know when questioning becomes recklessness. Kowalski saw a margin that existed but wasn't being used. He exploited that margin. For 3 months, it worked brilliantly. It saved lives. It improved mission effectiveness. It made the aircraft perform closer to what operational requirements demanded rather than what peacetime engineering caution had specified. Then one turbine failed, one aircraft was lost, and the margin disappeared. Not because the physics had changed, not because the modification had been proven unsafe across the fleet, but because the system couldn't tolerate the risk that the margin represented. The question isn't whether Kowalski was right or wrong. The question is more subtle. In a war where thousands of airmen were dying, where every mission carried the risk of not coming home, where the difference between 28,000 feet and 31,000 feet could mean the difference between survival and death in that context, was a 0.36% turbine failure rate, an acceptable price to pay for a 42% reduction in combat losses. The official answer was no. The unauthorized modification created risks that proper procedures were designed to prevent. One catastrophic failure was one too many when it resulted from deliberately operating equipment outside its design envelope. The unofficial answer, the one that lived in the spaces between regulations and reality, was maybe. Maybe in war, you make different calculations about acceptable risk. Maybe the rigid adherence to peacetime engineering standards costs more lives than it saves. Maybe sometimes you need mechanics who are willing to make a 2mm adjustment that isn't in the manual. History doesn't offer clean answers to these questions. The data shows that modified aircraft had lower combat loss rates and only marginally higher mechanical failure rates. The data also shows that one aircraft was lost specifically because of the modification, and 10 men died in that loss. Which number matters more? The hundreds of airmen who came home because their aircraft could fly 3,000 feet higher, or the 10 who didn't come home because a turbine exceeded its design limits? The engineers and administrators who wrote the regulations after the investigation would say both numbers matter, but safety procedures exist for a reason, and violating those procedures is never acceptable regardless of outcomes. The pilots and flight engineers who flew those missions would have a different perspective. They'd remember watching B-17 seconds cruise overhead while their B-24 seconds struggled through flak at lower altitudes. They'd remember the missions when altitude meant survival. They'd do the arithmetic differently. In the end, Kowalski's modification existed in that uncomfortable space where practical necessity and proper procedure collided. It worked. It saved lives. It violated rules. It caused a death. All of those things are simultaneously true, and history hasn't found a way to reconcile them. What remains is a reminder that engineering is always a negotiation between capability and caution. The designers at Consolidated and Pratt and Whitney and General Electric built margins into their designs because they knew they couldn't predict every operating condition, every possible failure mode, every stress that combat would place on their aircraft. Those margins were necessary. They prevented countless failures. They kept aircraft flying and crews alive under conditions that pushed machinery to its absolute limits. But margins, by definition, represent unused capability, and in war, unused capability has a cost measured in lives and missions and objectives not achieved. Eddie Kowalski found that margin. He used it. For a brief moment in the autumn of 1944, the B-24 Liberator became the aircraft it probably should have been designed to be from the start, a bomber that could fly high enough to avoid the worst of German defenses, that could operate in the same altitude band as the B-17, that could give its crews a fighting chance. Then the system caught up, the rules reasserted themselves, the margin closed, and the B-24 went back to being exactly what its specifications said it should be, neither better nor worse. Just designed. Up next, you've got two more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.